Hi there, it's Mrs. Goodson, and this video is about alkanes. And the aim of this video is to explain about the physical and chemical properties of alkanes. So you need to be able to describe the common uses of alkanes in everyday life and understand what alkanes are that are actually all around us. Also to explain the solubility of non-polar substances, and this links to Chemistry 2.4, and explain why alkanes don't conduct electricity, which is also linked to Chemistry 2.4, and to define melting point and boiling point, and explain why the melting point and the boiling point of alkanes increases as the carbon chain size increases, and link this to intermolecular forces. So just a reminder what alkanes are. They're made of carbon and hydrogen. They're hydrocarbons. They have only single carbon-carbon bonds, and their general formula is CnH2n plus 2. Methane is the smallest and simplest organic molecule, and it's an alkane. So if it hasn't got any other obvious functional group, it's probably an alkane. So we've got ethane, right up to pentane and octane. So the physical properties of alkanes, they're colorless compounds. They are non-polar, so they are insoluble in water. They have densities less than water, so they float on water. If you have a look at the picture I put down here, which is a glass of water with the oil floating on top. The oil is a non-polar substance. It is an alkane, a mixture of alkanes, and it floats on the water because it's less dense. It doesn't mix with the water because it's insoluble in water. It's non-polar. They do dissolve in each other, so you can use oils and greases to remove other oils and greases, and they act as solvents. They do not conduct electricity or heat, and that is because all the electrons are held in covalent bonds in the molecule. And as we learned in Chemistry 2.4, to conduct electricity or heat, you need charged particles that move. So if the electrons can't move because they're held in bonds, then it does not conduct electricity. They are insulators rather than conductors. The melting and boiling points increase as the length of the carbon chain increases. So the bigger the molecule, the longer the carbon chain, the higher the melting and boiling points. So we're going to look at that a bit more. Okay, so alkanes with carbons 1 to 4 carbons are gases at room temperature and are widely used as heating fuels. So this would be methane, ethane, propane, and butane. Butane has 4 carbons, and this is its structural formula. We've drawn it as this is like a little skeleton. It's a very short way of drawing butane. Alkanes with 5 to 8 carbons are highly volatile liquids. That means they're easy to turn into a gas, but they are liquids at room temperature, and they make very useful fuels. So we've got pentane, hexane, heptane, and octane. And the petrol that we buy at the service station is usually a mixture of different alkanes. And the higher the octane rating, the more octane there is in it. So alkanes make really good fuels, and the lighter alkanes, which are gases, when they are burnt, they produce less pollutants as natural when they come from natural gas compared to petroleum derived fuels. Some of the uses of natural gas are for heating and cooling and air conditioning, ovens to heat cook food, fireplaces and for heating, outdoor lighting, fuel cells, plastic products where they can be made into polymers, fertilizers, methane is used in that process, fabrics, antifreeze, and motor fuel. So these are really common and useful substances that we use all the time, but now we know that they're called alkanes. Just a couple of definitions here for you. So melting point is the temperature at which a substance changes from a solid to a liquid. And boiling point is the temperature at which a substance changes from a liquid to a gas. Okay, so they're both temperatures. Okay, so if you have a look at this table, it's the names of the alkanes. The carbon chain is getting longer. So methane has 1 carbon, ethane has 2, and etc. up to decane actually has 10 carbons. Okay, so the chain is getting longer. And then the melting point starts at minus 182 degrees centigrade. And it's, as you can see, as the carbon chain gets longer and longer and longer and longer, the melting point is getting higher. It's a negative number, so it's getting higher. And then the boiling point is also starts really low, and then it gradually increases. Now, room temperature is considered to be about 25 degrees centigrade. So if the melting point is lower than 25 degrees centigrade, then the substance is a liquid at room temperature. And also, if the boiling point is lower than 25 degrees centigrade, then the substance is a gas at room temperature. So I've put this red line here. This is so these 4, methane, ethane, propane, and butane, are all gases at room temperature. And I can tell that by looking at this data, because all these temperatures of the boiling point, that's the temperature it goes from a liquid to a gas, they are all lower than room temperature. So at 25 degrees, they've already boiled, they're already a gas. So, but pentane onwards, the temperature that it turns into a gas is higher than room temperature, so these ones are liquids. And if you keep going into really big alkanes, then you get into things like candle wax, which have long chain alkanes, and they are solids at room temperature. So the reason that they, as the chain gets longer, the reason that the melting point and boiling point increases is because there are stronger forces holding it together. So this picture shows a picture of the intermolecular forces between the non-polar molecules. Okay, so they're quite weak compared with covalent bonds, very, very weak. But as the chain gets longer, i.e. the molecule gets larger, the intermolecular forces get stronger. Therefore, more energy is needed to overcome these forces, and the melting point and the boiling points increase. So, larger the alkane, the higher the melting point and the higher the boiling point. So, the chemical properties of alkanes. Chemical properties means what chemical reactions do the alkanes undergo? Organic molecules can undergo chemical reactions. We'll start with the reactants or the ingredients and make new products. And the new products usually have different functional groups. When you're learning about chemical properties of different organic molecules, you need to know the reagents and the conditions needed, the type of reaction, and the structural formula of the products. You need to be able to draw that. So the first reaction that alkanes undergoes is combustion. So combustion is burning with oxygen gas. Complete combustion is when there's plenty of oxygen, and in this case, carbon dioxide and water are the products. The flame is hot and clean burning, and there is no soot. So this would be, the example would be the Bunsen burner blue flame. And so we start with, in this case, we've got methane with 1 carbon. It burns with 2 moles of oxygen and makes carbon dioxide and 2 moles of water. So 1 mole of methane reacts with 2 moles of oxygen gas from the air, and that makes carbon dioxide, 1 mole of that, and 2 moles of water. And you can see they're all at gas. So we've got steam being made, right? Water vapor. Incomplete combustion occurs when there's a limited supply of oxygen. And so either it doesn't make carbon dioxide, it makes carbon monoxide or even just soot. And both are formed together with water. So the flame is not clean and is yellow coloured due to glowing soot particles. And so this would be your Bunsen burner yellow flame. Okay, so then we've got if we have a look at the reactions, we've got methane reacting with oxygen. This is the only situation where you can use fractions in front of in a chemical equation. So we've got 3/2 moles of oxygen gas. Now we've just got CO, which is carbon monoxide. Now carbon monoxide is a really dangerous, poisonous gas. Okay, so if there's not enough oxygen, it'll make carbon monoxide rather than carbon dioxide. We've still got water being made as a gas, And even if there's not a limited supply of oxygen, some of the methane might only just make just carbon, which is that sooty stuff that we make when things are burnt, okay? So that would be incomplete combustion, which makes carbon monoxide and just carbon or soot. Unfortunately, if carbon monoxide is made, then and it happens where people are, then it's very toxic and poisonous. And so we need to be aware that when we're burning things, even like little gas burners or something, for example, in a tent, that would be a really bad idea because there's not enough airflow. Okay, so that you need to burn things in a well ventilated area. So people who get exposure to carbon monoxide could be inhalation of fumes from gas furnaces or heaters. This poisoning can be prevented, but unfortunately, every year hundreds of people die because of the exposure to the toxic gas. So that's why I want you to know about it, so that when you're burning something, that you know that the carbon monoxide can be produced, and you open the window and you make sure that you're safe. Okay, the other kind of chemical reaction that alkanes can undergo is substitution. So this is a type of reaction that where an atom on the hydrocarbon chain is replaced, and in this case, it's usually replaced with a halogen, which makes a haloalkane. So my example here is methane with bromine, which is Br2, and it makes bromoethane. So one of the hydrogens here gets replaced with a bromine atom. Okay, so that is what happens. So a replacement is a substitution. So we've got Br2. Now this is quite a slow reaction, and you need to know that it needs UV light to happen. Okay, so it breaks that bond with a hydrogen and makes a new bond with a bromine, and it could also happen with chlorine. Okay, so it could happen with HBr or Br2 or Cl2 or H. And then you could also then carry on and replace other molecules, other atoms on the molecule, I should say. Okay, so that's further substitution. But a way of detecting whether this has happened or not is because you could use litmus paper, and if the blue litmus paper goes red, then that is a positive test for hydrogen bromide being made. So in summary, alkanes are really good fuels, and they undergo combustion reactions, that's burning with oxygen. Alkanes are non-polar, and therefore they won't mix with water, and they're insoluble in water. They are molecular substances, so they do not conduct electricity or heat. The smaller chain alkanes are gases at room temperature, and the melting points and boiling points of alkanes increase as the carbon chain length increases, and this is due to the increased intermolecular forces between the molecules, so more energy is needed to overcome these forces. Alkanes, so the two chemical reactions are combustion and then also substitution. And a substitution reaction is where a hydrogen atom is replaced with a halogen, which is group 17, for example, bromine, and then the reaction is slow and requires UV light. So that's all you need to know about physical and chemical properties of alkanes.